Hybrid diesel-electric power systems in partnership with the University of Ottawa and ZEC Wind Power.
Today, many Canadians enjoy access to reliable and affordable electricity. However, this is not a luxury shared by all, such as those in northern communities. These communities are small and geographically isolated from major population centers. For these reasons, connecting northern communities to large-scale electrical grids is not economically viable. This is why over 300 northern communities in Canada rely on diesel generators for their electricity. Unfortunately, diesel-electric power is not the best solution. It is a contributor to social, economic, and environmental problems, such as the burning of diesel produces greenhouse gases and other harmful emissions which contribute to global warming and can negatively affect the local population's health. In addition, the high costs associated with the purchase and transportation of diesel can impact the local economy's ability to grow and prosper. Renewable resources such as wind and solar power have tremendous potential in northern communities as an alternative to diesel. However, there are limitations on these energy sources. Wind power can only operate within a certain range of wind speeds, and solar power relies on the availability of the sun. Alone, these sources are not a suitable alternative to diesel generators. The solution to this dilemma is a hybrid diesel-electric system. Here's how it works. When the sun or wind is available, these two sources provide energy to the system. This energy is used to charge the battery bank. The battery bank will then supply power to the load. When the battery cannot meet the demands of the load, the diesel generator will kick in as a last resort. The control of the system is all facilitated by a charge controller, which is responsible for voltage regulation and conversion. Now, an industry representative from ZEC Wind Power will present his role within the project.
ZEC Wind Power is working with power engineering students to implement its novel wind turbine and controls design into their prototype hybrid system. The ZEC Wind Power turbine has many advantages, from higher annual energy production to lower maintenance costs, and in the end, a larger return on investment. We look forward to working with the power engineering students on their prototype affairs.
The hybrid microgrid system was designed by students from the University of Ottawa and was implemented at ZEC. The prototype is composed of a power supply, an actuator connected to an induction generator to simulate a wind turbine system, a PLC controller, a frequency generator, as well as an adjustable photovoltaic system. Once it is completed, the prototype will be used as an open-ended test facility for student projects. Integrating this prototype with the ZEC wind turbine design, a diesel generator system as well as fuel cells will also serve as a basis for the hybrid microgrid system. The continued collaboration between ZEC and the University of Ottawa will allow for further technical and economical analysis to be conducted in hopes that one day this prototype can be implemented and pave the way for a future where energy shortages, high electricity costs, and complete reliance on fossil fuels are no longer a major problem for these isolated communities.